So the internet protocol we called as IP. Okay. So IP, we all know that's a unique identification that's give uh, to the network devices, right? What are the network devices? Like your
Any computers that are on the internet or any other devices that are connected to the internet, like your
yes,
router,
yes,
Internet of Things, if you, anything, refrigerator, anything that will be through a wireless internet or
yes, like
In
our phone.
resources under a network, all those things comes have IP.
Yes, for example, smart TVs, phones, mobile phone, laptop, personal computer, IoT devices like fridge, fan, AC. Then yeah, even the Tesla have IPs, right? Nowadays, the smart.
yes, yes.
So for each devices, okay, each devices have some unique numerical label assigned. Okay, that is called.
That is called IP address, right?
Yes.
Vic, your voice is not very audible.
It's breaking, right?
Your voice is breaking.
Now it's clear.
Yes.
Yeah, better.
Okay, fine.
Periodically, there are some bandwidth issues, so we just have to tell him to repeat some sentences.
Hmm. Actually, I am tethering my phone. That's why. But having 5G connection. Okay. So we can define IP as IP address is a unique numerical label assigned to each devices to connect a computer networks that uses the internet protocol for communication. Got it. So, for example, consider this is our home. Okay. So inside our home, there are different phones, right? Mobile phones, laptops, TV, so many things are there. Consider we have a internet connection. Okay. So I will explain one phone here. There is another phone, one laptop. Okay. So we have internet connection also here. Okay. There is a Wi-Fi router in our home. Okay. So there is a modem is in our home. This is a modem. Okay. So can anyone say what are the technology or what are the things happening when we connecting to this specific Wi-Fi here? This there is a Wi-Fi connection. Okay, like router. This is a router. This is a Wi-Fi router. Okay, so inside our home there is a Wi-Fi signals, right? So these machines, I mean these laptops, um, and the mobile phones, all we can connect to the router, right? This is a router like Wi-Fi.
Packets move over the network based on the address, and there are packets for request and post and get, and those according to the IP address, the packets actually move through the whole network, but they are received by the final address. And the packets have a time to live so that they don't keep
Yeah.
flooding the network by
My question is for this mobile. Okay, this mobile user needs to send a Gmail. That's a requirement. So how it happened?
Actually, every device has IP, and it has IP is divided into two parts: host name and address name. So they will send the signal, and the address within this network, the address it matches, and so the it will catch. Uh, it works like that.
Okay. There are two type we classify IP address. Okay, one is private and one is public. Private IP and public IP. Okay. So yeah, here our requirement is to send a mail. Okay, send a mail to. I mean, yes, send a mail. Yeah, that's fine. So these devices doesn't have any internet connection. Okay, only we need to connect with the router because in our home we have a Wi-Fi connection, so we can directly connect our Wi-Fi. So during turn on the Wi-Fi, okay, we need to search a Wi-Fi device, then we need to connect the device. Okay, so each machines, okay, what are the machines connected to this router got a IP, and which IP these devices getting from the router? Any idea? Anyone? Public IP or private IP?
Private IP.
Okay. Yeah, right. Because the router have a dynamic IP configuration protocol there. That is called the DHCP. Okay, DHCP is nothing. It will send IPs, some private IPs to connected devices. That IP is purely private IP. So who are connected? Okay, for example, this machine connected to this router. So the router will assign an IP. Okay, for IP means a private IP. Like uh, yeah, we use the private IP for creating VPC. So this would be the IP 10.0.0.1. Okay, then this mobile device is connected to the router. So what will be the IP? These are the same, only changing the last digit. Okay, like 10.0.0.2. or any
I have one question. How it is calculating like the last only is the IP of that particular
yeah,
machine and rest is the address?
I
yeah,
think it counts up basically, right?
yeah, that I will
Mm,
explain. Yeah,
okay.
I'm going to. Yeah. So the next is this laptop as connected to our router. Okay, so the IP will be like 3. Consider like that. Okay, 10.0.0.3. Okay, so these all machines are connected to the router. Router is already connected with our modem. Okay, so consider each devices have internal connection, right? And this modem have one IP. Okay, that IP assigned by the corresponding service provider. For example, this service provider may be Airtel, like Geo, anything like that. Okay, so they will assign a public IP for communicating with the internet. Okay, so our modem have one public IP. Public IP like 20.0.1.165, any public IP. Okay, so our modem have one public IP, and the devices connected with our router have private IPs. Got it? So for this device, okay, mobile one needs to send a Gmail. So how this happen? There's when sending connection, okay, I mean sending to the mail to the Gmail, first it hitting our router. So the router know there is a connection. I mean some request coming from the IP 10.0.0.1, and that device needs to connect with the Gmail, right? Gmail, DNS or anything. Okay, that is purely in internet. So it's connected, needs to connect with the Gmail server. Okay. So the routers routing this mobile traffic and pointing to Gmail. So the Gmail knows there is a connection from not this device IP address. Okay. Only the Gmail servers knows there is a connection from the modem IP. That is the public IP. So from modem to the Gmail server, okay, the connection via public IP. So the Gmail responded, okay, there is a response. We will get a response from Gmail server, or it will send the details, okay. Like first it will only gives to the modem IP, that is public IP, okay. Then again it's go to the router. Routers know that the request coming from Gmail. So the router job is routing the request to the correct machine. So it will go back to our requested machine to this IP. It is a simple scenario of how a local network and a public network works. Got it?
Okay.
So we all are connected, right? You all are from US, Canada, or I'm from India. How we connected? Any idea?
So
Because we
you
have a
have,
unique IP, right?
yeah, well, basically your modem is internet facing and it has a IP that uh, reaches, we can reach, and then it probably assigns you some private internal network where it maps, like, each device to who it is, because uh, you can't have too many IPs in the world, right? So
Yes.
and then you probably have some keys on your computer that authenticate you to log in. So we are currently getting all this information through a server, right, on Zoom,
Yes. Yes.
and that same server is giving you and us all access at the same time.
Yes. Yes. So here you can see this is my public IP. Okay. So if you are checking, then you will get a unique
So we should
IP
Google on our.
as well. Yes. So uh, my question is, only I have this public IP, or I have a private IP too? Any idea?
You
Private
have
also.
both. You have both.
Both
Yes.
actually.
Right, right. So where we can find that thing? Just go to the internet option here. Then
So I have a
it's
Wi-Fi.
11 actually. Yeah. Yeah, there is an option in our
With ipconfig command it will come, right?
yes, right.
That give all the details. Ipconfig.
So here, this is my IPv4 address. See, my local IP. I mean private IP.
Can you show the command again? ipconfig that what do you put?
IP config. That's all. IP config, or if we choose IP config forward all, it will shows all the things.
I typed that in on my Mac and I got like usage
For
ipconfig
Mac,
command
type
args.
if config.
If config try.
Try ifconfig, okay.
Hmm. For Windows, IP config.
So it gave me bridge 0. So my inet is 127.0.0.1.
127, right?
Yeah. And then
No, that's your loopback address.
loopback, okay.
127.0.0.0.1, right?
Yeah.
That's loopback. Loopback means it's a dedicated IP. I mean that IP for our loopback each machine. Okay, your computer, laptop. There is a loopback address that is dedicated for a loopback service. Loopback service means that IP is when we are using that IPs means for example we need to test something. Okay, for example we need to test we deploy some application in our own machine. So how we access the application using the loopback address? So just open the browser and 190 127.0.0.1 we will get the application. So that is permanently dedicated for loopback. Okay, so this is uh, way of communication with IPs. Okay, in this scenario, we use two IPs. One is private and one is okay. Public IPs mostly we will get from the cloud provider. Sorry, service provider. Service provider means the
The
internet.
browser refused to let me get the connection. And I tried 127.0.0.1.
Yes, yes, because you didn't deploy in your app in anything in your laptop. We need to
Oh, okay.
deploy and we need to configure. I mean, pointing to the loopback. After that,
Okay.
okay, so loopback is done. So uh, I think all of you know that the internet connections happening across the globe using optical fibers, right?
Yes.
For example, um, you are in US region, okay? This is US region, and I am in India. How we connected? I mean, via internet. Any idea?
There is an optical cable, undersea optical cable network,
Yes,
and there are many computers connected on that network, and the packets hop across the computers until they reach their final destination. So
yes,
they will route the to the like the uh, they have some algorithm through which they route, and they start getting closer and closer to the final destination.
right, right. So we are communicating via optical cables, okay? Some huge cables. So consider there is a stations. These things are handled by the provider or the government and thing like that. Okay. So consider there is a station from the station to the next station. Okay. There is a cable. This is called fiber optics cable. Mostly this is under the sea. Okay. So this is a strong cable. Doesn't affect from any ship or the a shark or anything like that because this is purely strong cable. Different layers too. Okay, means these cables relying in full time in water, right? Under sea. So this way the communication happen. Okay. First there is a backbone. This is considered this is a backbone. Then from the station, they will provide connection to the service provider like Geo or Airtel like that. Then they will using the antennas like big size antennas. So the users can connect. I mean, they will get, for example, they have mobiles. Users have mobiles, so will get mobile ranges and they will connect to the station. Then connection goes to the main station. Then connection via going with the cables. Same happening in India and any region. Okay, like so. This is a way of communication happen nowadays. If this consider this cable breaks, okay, what will happen? The communication breaks. For that case, they have one more cable like that for
Tofik, one quick question.
yeah.
So we are saying that we are connected through fiber net, right? So
Yes.
why are we having the towers placed now for the mobiles? And how is that towers getting connected to this fiber net?
No,
I
no,
would
no.
say signals hop between, like some signals may travel wirelessly, but there is probably a optical cable that connects
Yes.
towers. So the signals will come through optical cables and they'll be sent by electromagnetic radiation
Yes.
wirelessly to other locations.
Yes. From the antenna to the user. Consider from the antenna to the user, we are using radio optic, okay, waves. So we use the radio optic waves to communicate with the tower. Got it?
So are we saying that fiber net is all the towers are connected from fiber net? So there
Yes,
is no
most.
satellite. There is no satellite work over
No,
here.
no, 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 no satellite. There's no satellite in between nowadays fashion.
On the airplane, you get a satellite internet, I think.
Yes. For specific needs, we are using satellite, not you and me. I mean, the one who nowadays using internet purely happen through fiber optic. I mean, these connections.
See, why I'm asking, why I'm getting these questions is that, say, when we have towers in place, uh, if it is connected to a fiber net, uh, then there are many complaints that I mean, like, because of the frequencies that they maintain, high frequency, low frequencies, okay, receiving frequencies.
Hmm.
So there is lots of problems. I mean, like we also saw the Robo 2 or Robo 3, right? So that's how uh, uh, I mean, like they have problems, right? Receiving end the frequencies because of the frequencies. When we are connected through fiber net, why are we having those problems receiving frequencies and other stuff?
Hmm. Yes, I will explain one thing.
What is Robo 2, Robo 3? Krishna.
That's a movie.
A movie, okay, right.
This is considered this is a station in India, okay? India. So there is a huge optical fiber connected to this station. Consider, okay? So this from this station to the cloud provider. Consider Geo. So Geo have their own substation. Consider Geo have their own substation. then they will connected with their antennas. Okay, for example, this is in Mumbai. From the antenna to the users, okay, users are belongs to here. From here to users, they are using waves. So where you have doubt in this scenario, Krishna?
Yeah. So right now from the hub mainly, those are wired connected, fiber net connected, right?
Hmm.
Okay. I got the picture now.
Yeah. So the users can access the internet connection using their phone, laptop, or anything. Okay. This is only for the communication with the mobile phone, actually. Okay. For example, Geo have other connectivity like home network, like similar like that. So for that, they are using this cable. I mean, optical cable. For example, there is on home here, so they will need to take a connection from the Geo connection. So Geo will install a cable connection to our home. This is purely optical cable.
Mhm.
And same thing happen, like this thing happen inside our home. Like we have a router here, Wi-Fi router. So again, it will send the waves, sort of magnetic waves to access internet who are inside our home. Got it?
Okay, okay. Got it. Thank you.
Okay.
You mentioned that the private IPs are dynamic. So does that mean they keep changing? Like while a device is connected and not connected?
Mm, yeah, it's changed because uh, there are two way we can give an IP to a specific device. For example, this is my laptop. Okay. So when coming to the internet and networking thing, we can define a private IP. I mean, we can assign an IP to this machine. Okay, a private IP. And the next thing is there is two options. One is manually we can define IP, or automatically it will get IP when connected with any other device in the sense of like router or anything. Got it? Two way we can assign IP. One is purely automatic, one is manual. For manual, when we given manual IP means that is a considered a static IP, static private IP. That IP won't change. If we choose automatic, uh, then it will assign by the router. Okay, so that is not a static IP because whenever turn on the machine and yeah, turn off the machine and turn on, again the routers know there is one machine connected. Then before that it's a release. Okay, when we turn off the router, know the connection loss, so the router will release the IP. Then again we join. Okay, I mean turn on the machine. Then routers know. Then routers send another IP to assign this specific machine. So two different way we can assign as per our needs. Got it?
It's funny how so many devices are just autonomously working in this world right now,
Yes,
right?
yes, yes, yes. For I mean,
We don't.
yeah, we when we working with 20 or 10 or 20 machines, we can assign IP manually. But consider there are 100 or 500 machines, it's difficult because we need to go each machine and set the IPs and knowing the IP and noting the IP. That's the messy thing, right?
Yeah.
So that purpose, there is a automated tool like DHCP. Okay, dynamic host control protocol. There's a protocol. That protocol's predefined in routers actually. So we just enable the service. I mean the DHCP we just enable the service in router. Okay, so the router manage assigning the IPs. We didn't bother about that. So what are the mission? I mean, whenever a mission turn on, okay, in the network, in the local network, consider, for example, this is considered a lab. Okay, this lab have 500 PC, like PC1, PC2, PC3, n number of PC. Okay, so manually we are saying IP is messy thing. Okay, so that we will these all machines are connected in the local network, right? So there is a router there. Okay, so in router there's a configuration DHCP is there. So we just enable the DHCP. DHCP is a service to assigning IP address within local network. Okay, this is our router. So each machines are connected to router, right? Not to router. There's a switch behind the router. Each machine is connected to the switch, and this switch connected to the router, right? So when we turn on the, I mean, enable the DHCP service, for example, this machine turn on. So the DHCP is now. So DHCP send a IP to this machine. The IP pool and all things we need to set before, okay, in DHCP. For example, these are our IPs and the starting IPs, this ending IP, this like that. So another machine turn on, same thing happen. DHCP will send, I mean, assign an IP to this machine. This machine turn off, DHCP no. So DHCP will release the IP and again another machine on, okay, consider. So this IP will be assigned to this machine like that. Got it?
Yeah, got it. So you are saying if it is automatic, then it's dynamic. If it is manual, then it's static. It doesn't
Right,
change. For
right, right.
example, if I set up an IP for the first machine manually, it will not change. Whenever I turn on the
Won't
machine,
change,
it
won't change.
stays the same.
Yes, yes, yes.
That means it is freezed for this particular machine and not any other machine is not able to select.
Yes.
Okay. Okay, got it.
So next we need to, I mean, the classification, okay? And there are different class in IPs, okay? That's the main thing. So
Wait, do we have any training material with you?
training materials,
Yeah, I mean, like, is
we didn't have any materials, but when coming to DevOps, we have some materials. So that I will share during the time. And currently we are keeping this section as, I mean, we keep recording each section. So you can go through this section, okay? If you have any doubt.
okay?
One more question. So does that mean all public IPs are static?
Yes.
Or like if
For
for
example,
example I have decided,
yeah, there's pure
yeah, go
example
ahead.
is turn on your device, okay? I mean mobile phone, and you turn on the internet connection, okay? So the service provider will assign one public IP for your phone to communicate with the internet, right? So when you turn off the internet option in your phone, if the service provider knows the connectivity from your phone and the internet is turned off and the IP will release. Got it?
No, but if my phone is turned off, even then other phones in the house are turned on and
No, no,
it's
no.
connected to.
I'm talking directly. I mean, not through the your network. I mean, directly we can connect internet, right? When I mean you are now out of your home. So how will you connect
Yeah,
internet?
yeah, yeah, yeah,
For
yeah,
that
correct.
scenario, we will get direct IP.
Okay,
You know the difference. I mean, inside your home, we have interconnection, right? We have actually two
correct.
interconnection. The first interconnection in our home, okay, that depends on the modem and all the things. And you
Yes,
have your own interconnection in your phone because you have the SIM
correct.
and you have
Yeah,
a valid subscription. I mean the interconnection. So these two are different. Okay.
got it.
Yeah.
Topic. For example, if I'm out of network, for example, I went out, okay, out of my Wi-Fi, I'm like from my house, and then came back.
Hmm.
So do I have a different IP address again, or will I have the same IP address when I left?
No, 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 no. You will get different IPs when you turn on the network actually. I mean,
Got it. Got it.
yeah. That is depends on the time actually. For example, if you uh, turn off the interconnection in your phone and turn on at the same time, at that time I think you will get the same IP. But if I mean turn off the interconnection in your phone and you wait for 5 or 10 minutes, then turn on again. Then you will get different IP.
Now, consider an ideal scenario here. Okay, I just went out for shopping and then came back. So in
Hmm,
this scenario, when I left, for example, I had 192.168, something like 1.20.
hmm.
Okay, so will I have 20 again when I come back, or will I have something like 1.25 or something?
Yeah, it will change.
It will change. Okay. Yeah, thank you. So it's not static, then it's a dynamic one.
Yes. So coming to IP address, okay, coming to IP address, the IP address are divided by different classes. Okay, here class one, sorry, class A, then class B, class C. Class D and E. Okay. So each class as per the requirement actually. For example, we need to set up a small size internet connection or we need to set up a big size or a large size. Okay. So as per the requirement, we need to choose corresponding IP classes. Okay. So that IP classes have that much IPs. That's a simple way we can say. For example, then class A, the IP ranges start from 1, 0 to 126.255.255.255. So this is a class one, okay. So the class 1 IP starting with 1.0.0 to 126 to 255. Okay. Then the continuation from class A to class B, the continuation of 126, right? The continuation of 126 is, before that, I will explain one thing. So the IP, okay. So the IP number starting with the 0, okay. 0 to 255. Okay, 0 to 255 is the maximum capacity of a, this is actually called a octet, okay. That's why when we are digging more into IP, we need to go with some mathematical equations and some things. That I
8-bit
will,
number.
yeah, 8
2 to the
bit,
power 8.
yeah,
2 to the
power
power
of
8
8.
is 256. So if you start counting from 0, you'll reach 255.
Okay, actually we have it for IPv. Yes, this is actually we are talking with IPv4. Okay, so IPv4 have 32-bit divided by this 32-bit is divided by
4
octet. Okay,
sets
4
of
octet.
8. Yeah.
4 octet we define like this. Consider this as 0. Then we need a point 0 0. Again there is a dot. Then 0. Okay. This is first octet, this is second octet, and this is third, and this is fourth. So each octet have 8-bit. This have 8, 8, 8. So that we called as 32 total. Okay. So in first octet, the range is 0 to 255. Okay. The second one, 0 to 255. So you see here, these 3 octet completed, right? I mean, the last one is 255. There is nothing from 255 or like 256 or 257. There is no from the 255. Only 0 to 255. So the continuation. Now you know that the final is 255, right? So first this last octet will reach the 555, 255. Then it will count from the second last one. Okay. For example, we start from 0, then end with the 255. Then it's completed. Then same scenario happening here, starting with the 0 and ending with the 255, like that. Got it? If this, the last octet, I mean the second octet, okay, this is the second octet. The second octet reaching 255, then we can directly jump into 127. 127.0.0.1. This is the next phase, right? But this IP we didn't mention in this IP table. Why? Because the 127 is dedicated for loopback. Got it?
Yeah, they're all allocated for their special reasons.
Yes. So the class B start with which one?
127.
No, 127 is already dedicated for
128.
loopback. You're right. You start with the 128. For this classification, any doubt like how this happened 120 to 250 by 255? For example, I will give a simple scenario.
126 means I didn't get that
Huh?
126 one. 255 is the
Uh,
maximum one that I
yes,
got, but why
that,
it
that
started with
yes,
126?
that's actually the next thing we need to learn. Like each IP address have two part. Okay, I will take this free space. Each IP address have two part. For example, this scenario. Okay, I'm taking 126.255.255.255. Okay, so this is my IP. Consider this is my IP. I told you when we are choosing the class, different classes are in IP address. Okay, class A, class B, class C, and class D, class E. So this selection of IPs depends on our requirement, right? For example, I need to deploy a large network. The large network, for example, IBM, okay, IBM, Entity Data, they have huge network, right? There is a lot of employees, lot of machines. So consider they have to set up a large network. So they will choose maybe the IP class A, okay, or B as per the requirement. So consider we have a small business, a small business corporate office. The corporate office have 50 to 100 machines. Okay, that's our extended version. So for that scenario, we need to choose some other classes. Okay, so that's all depends on our requirement. As per the requirement, we need to choose the classes of IP. So how we choose why we choose the IPs? So that depends on each IP address have two part. Okay, so the part first is for the network part, and the second part is host part. Or network part means how many networks are we need to deploy. Configure in our office or organization, anything like that. And the host part means how many IP addresses that we need to assign for specific devices or internet device, network device or internet. Okay. So in this scenario, this is a network part. This is the network part, and this is the host part. Okay. You got the idea. So, for example, I am using this IP. Okay. Consider I am using this IP means class A IP. Okay. Okay. So this is my first IP. Consider this is my organization or the machines belongs. Okay. Consider this is a building and this building. There is two building. So I am choosing 126, the same IP. This IP, okay, I'm using this IP for my machines. So how it will allocate this IP means this is a host part. So this host parts have around huge number of IP, okay. For example, I am going to, here is a machine, okay. So the first machine IP is consider like 126, okay, 0, 0, 1. This will be the IP of the first machine. Dot, dot, dot. Got it? So
Yes.
consider this building have 250 machine, 255 machine. Okay. So this is the first mission and this is consider this is a 255 fifth mission. Okay. So this IP is starting with the 001 and ending with 0, 0,
255.
126. My mouse have some issues.
You can use the text box maybe.
126.0.0.255. 255, yeah, 255. Okay, that would be the IP ranges of this machine. Okay, this consider this is the first row. In this office, first row have 255 machines or 254 machines. There is another row. Okay, the second row have same 255 machines. I mean 255 employees. That because that huge organization. So the next IP starting with the where, I mean which starting with the 126 dot
126.0.1
0 dot right 1
1
dot 0.
dot 255 right.
Got it. And it end with the only
255 255 right.
no 1.255.
1.255.
1.2.
Okay.
Then
126.0.1.255.
same 26 dot 0 dot 2. Again, these network are changing. Okay, see here the network change. What this is actual network. Okay, so it's changing again 2, then 0, and ending with 2.255. So it will go where the second is hitting 255. I mean this end like this 126 0 dot 255 dot 255. This is the ending of the this second last octet and third octet. Then it's again starting with the 126 dot 1. Got it? Dot 0 like that. It will stop like 126.255 5.255.255. So this is actually a huge network. When we, I mean, when we consider this IP, we will get lot of IPs that we need to calculate with the bit actually. Okay, so this is a way we are using class A. So similar way we need to choose class B starting with the 128. 127 is dedicated for loopback. So we didn't mention in the class actually. I mean that loopback IP address. So the class B starting with the 128. Starting with the 128 0 0 0 0 to 192. Sorry, 191. 191.255. 255. 255. 255. Okay, this is a class B. This class have less when comparing with the class A. This class B have less IP address. So this is for we can choose for a medium size organization. Okay. Then class C.
But in this IP class range, the first part, everywhere the first part is network address and remaining third part is host address, right?
Yeah, second class B have yeah, I'm going to that scenario.
Okay.
This have the first two octet is network. And the second two octet is host. The calculation like 2 into 2 raised to 24 and 2 raised to 8. That's the calculation actually. 2 raised to 16 for the host and 2 raised to 16 for host part. It's divided. Actually, this is balanced version. Okay. Like half for network and half for host. And the above scenario class A, how we calculate like 2 raised to 8 and 2 raised to 24. 24. 20. So we will get 32, right? 24 plus 8, 32. Total we have 32 bit. So how we calculate for host and for network? We use 2 into 8, 2 into 24. Then that is for class B divided by 2, 2 raised to 16, 2 raised to 16. And class C, we are commonly we are using class C, okay? That's for a middle or small size organization. So mostly we are working with the 192 series. So class C start with the 192.0.0.0.2 ending with the 223, then 255, 258, 258. Okay. So this part, this IP, the network and host divided by 2 into 24.
It's all binary arithmetic. So 128 is like the halfway point, and then you add 64, you come to 191. It's not 64, it's 63, because if you wanted to have 64, it's that extra bit, spillover bit, right?
So yeah. So this have 24, first 24 bit we are allocate for the network and the 8 for host. So what will happen here? Yeah, these part are for network. Only the last octet for host. So how many machines we can say? Anyone? When we are choosing,
What's the question? How many machines were in the class C network?
it is
Last one will
for
show
C.
host.
2 to the 8 machines.
2 to 8. How's around?
There are more networks than less machines in each network, right? 2 to the 8.
2 raised to the 8th power is 256, right? So we can say
256, yeah, 256 machines.
250 IPs we will get when we choose with the class C.
Yeah.
Got it? That's all. I mean, that's the power of the, how we calculate using 2 raised to the power of is 256. So 2 is 2, this is 2 raised to the 8 power of 26 actually. So that all allocate for the network part for the class C.
Your voice is cutting up.
Now it's clear?
Yeah, now it's clear. Maybe you might have to repeat the last sentence, I think.
Yeah, how we calculate the host and network using the IP. Then class D and class D actually reserved for multicast purpose. So we didn't, we are not working with the class D and E. So just keep in mind that start with the 224. 224.
One quick question. The first octet starts from 128 to 191. That is like they're saying that 64 possible values. Why is it that it starts only with 128? Any reason?
Can I answer that?
Yeah, please go on.
So sure. 128 is, I think 32 is the fifth power, then 64 is the sixth power, and 128 is the seventh power. Now, if you wanted to write 128, actually you would have to, you need 8, I think you would need 9 bits, right? The ninth bit will be, the first bit on the left side will be 1, and there will be 8 zeros behind it, right? So if you, so it all, because you start counting from 0, like let's say we have 0 to 9 numbers, right? So that's the 10 numbers. So when you go to
Right.
10, you carry the 1 to the tens place and you write 0 on the ones place. So that same logic, I think, is why the numbers, like, because they wanted to save 127 for loop back, right? So they could go to 126, then they made 127 dot the loop back. So then the next number comes is 128. Does that make sense?
My question is like, do we have IP address starting with 1.00 something like that? With 1. But like IP range is starting. See, what I'm seeing in the internet is that the first octet starts from 128 to 191. Okay, so it has 64 possibilities. So my question is like, uh, why it is from starting from 128 to 191 only?
Because the class A is
No, no, no.
allocated.
We have class A. You can see class A, right? So the class
Yeah.
start with the 10001.
Okay. So that class, is there any specification or any, like, how do we get that IP addresses? Why
These all IP addresses are private IPs.
private IPs? Okay, got
So
it.
we can assign as per our needs actually. As per the requirement, we can choose these IPs, class A or class B or class C.
Okay, got
That's,
it.
and the IP address starting with the 0001 and ending with the any idea, anyone?
255.
Yes, that's the ending of all octet, right? So we can directly say 255, 255, 258, 258. That's the ending.
Yeah.
See here, the last octet is, class C last ending with the first octet is 254. That's the last ending, okay, not 255. Because if this is 255, then it again starting, right? Like 000. That's why this is ending with the 254, and all the other octets ending with the 255. That's the ending. So the class D and E mostly for class C, class D for reserved for multicasting and future use. It's D, and E for reserved for experimental purpose. Okay. This is for experimental purpose. Experimental purpose. And D for multicasting and future use. So these D and E reserved by the IP association like ICANN or anything. And we are mostly working with the A, B, and C. And mostly we are using C class actually because that's uh, common scenario. For example, we have a school, hospital, colleges. Whole scenario we are mostly choosing C classes. And coming to multinational companies like MNCs, Tata, Apple, Google, they are using big size. I mean, class B or A because they are huge organizations. So their network is large. So as per the requirement, they will choose the corresponding network. Sorry, class. And coming to our scenario, okay, that's point I will add. So now you all know so which IP that we need to choose, right? So coming to our sections or when we configuring network in cloud, we are mostly using three types of IPs. First IP range should be like this, starting with the C10 dot 0 dot 0 dot 0. Okay, this will ending like 250 10 dot 255 10 dot 255 dot 255 dot 255. The second like 172 dot 16 dot 0 dot 0 to 172 dot 31 55 dot 255. 192.168. So we are using these classes, okay? For example, when we configuring a VPC, we can choose any IPs from these ranges. If you go with the 10 series, you can choose a 10 series and go with the 172, then you can choose 172, or you can use 192. You can go with the 192 series. So when choosing IPs, okay, for example, we are choosing 10 series, okay. So we need to provide the net mask for the VPC when creating VPC. So how many IPOs, I mean hosts are included in the VPC we can see. That all we need to calculate before creating the VPC. So the calculation like when we're choosing the first this series like 10.00, we will get actually 160 this much IPs. 7 this is one actually, okay, 1677 7216 216, that much IP address in this.
Range.
Yes, that's the most one, okay. So we will actually divide this IP using the net mask, right? If we use the net mask, then we will get that much IP. For example, if we are choosing 16, net mask 16, then this is dividing from this total IPs. Like we will get around 65,000 or like that. For this, the most one is all are as per the requirement, we need to choose the IP, okay? 1048 576. This is a top IP, I mean, using this IP 172.16.0.0. And when we choosing 192.168, we will get only 65,536. Got it? Any doubt?
No, those are just how the numbers come out, right? You
Yes.
multiply that many.
Yes.
It's a
Shilpa?
mathematical calculation there. We
Yes.
got the means overall idea how it
Yes.
what to use according to the
Yeah,
requirement.
Shilpa,
got
have
it.
any doubt? Or are you okay
No,
with
no.
the IPs? So
No.
and yeah, when coming to our learning, okay, we need to choose these IP ranges actually, and we need to know how many IPs are in each IP address, right? Or we can divide the IPs, or we can divide the IP using the net mask. That we already completed using when creating VPC, right?
Right, right.
Any doubt? Anyone?
Are you going to explain the net mask in the next lecture? Because I know the net mask is just how many bits are decided, right? Because
Yeah, net
whatever
mask
bits are not decided are left over. That's how it
yes,
divides the.
It's like divide, right? If
Yeah.
dividing
means
actually.
in a
Net mask
subnet,
is simple. I mean, subnet calculator. See, I am using an IP, okay? 10 series IP. I don't know how many hosts belongs to the IP. So that's why we are using subnet calculator, okay? So here we can choose the corresponding net mask. Net mask starting from 0 to 32, okay? So 10.0.0.0. Okay.
That's only one computer because that 32 are
Yes.
covered, right?
Yes. So how many hosts, how many IP addresses we will get? Only one. So we need more. For example, our
The
requirement
bigger,
is we need to hold
the,
50 machine. So what will we do? Here we can directly see how many hosts. So 64 is here, right? So we can choose the net mask to the 26. So we will get 64 IP. So the IP and the net mask should like 10.0.0.0 /26. Or we need more machines. That's our requirement. So what will you do? We can choose.
make the net mask smaller and smaller, more and more machines fit in it because then the
Yes.
more bits are open for changing. The
Yes.
net mask locks in the bits, right? So if you lock all 32 bits, then there's no flexibility. If
Yeah.
you lock 26, then the six are still left to change. So you get 2 to the 6 number of addresses.
We are
It's
mostly using 16 net mask actually. Yeah. So we will get 65,536 IP ranges inside the IP. of the network.
So you have to remember backwards, right? Like the bigger the net mass, the less computers fit.
Lesser computers, right? And for this IP, we can see that input long. This is the input long. I mean the total IPs that we can define. Okay, that I already wrote in here. See. So this way we will calculate IP address and net mask when we configuring VPC in cloud. In a simple scenario, we need to create a VPC and that IP ranges should like 65,000. So what we'll do, we can simply using the IP, the public IP like 10 dot series and the netmask should be 16. The task is done. Then we need to create subnet, right? Create subnet and allocate the IP to the specified subnet. So the network part is completed. Got it?
Okay.
So choosing the IPs as per the requirement. And for example, we need to learn, right? We are currently learning. So we can go with this small IP ranges. Doesn't need like 65,000 or like that. So we can choose 192 series or anything like that. So it will like below 250 IP ranges are there. Okay. If there is no doubt, then we can wind up the section. All are okay?
One last question. So these IP you talked about, they're all public, right? Because they're going to be shared over the world. But whatever you
This
not broadcast, you can be private.
uh, the IPs that we talking, these all are private IPs,
Oh, okay.
not public.
Oh, so it's your internal network you made, basically.
Yes, yes.
Okay. But
All
you
are
could have
private.
some device that talks to the internet.
Yes. So how the internet works? It's a collection of local area network, right? For example, you have a office and you streaming or you have some movies database or movies. Okay, so you have a local area network. This is your office, and consider you have a small size application like Netflix. Okay, so I also have one application like Amazon or Amazon or Hotstar like that. So I have one land over here. Okay, so we connected with the internet. So the people who connected with the internet access our application, right? You got the scenario, right? Actually, internet is a collection of local area network. Each local area network sharing their resources. The resources, in this case, the resources is movie streaming. Some resources like Flipkart, Amazon, they are offering products like that. So they have their own local network actually, and they expose their application to public through internet connection. So each organization or each resources relying in a local area network. So the collection of local area network we called internet. Got it?
That is why it's called internetwork. It's a
Yes.
network of between
Networks of
networks.
network. Right, right.
Yeah. Like international internet, right?
Yes. For example, you have a office and consider you have an office, there is 10 PC. So first, how we configuring the infrastructure like cabling, then putting the jack to the PC, then buy one switch, then plug it all the switch, PC to the switch. So we can say that is you create a LAN, right?
Yeah.
Local area network. Then you buy one modem connection, and put the cable to the, switch to modem. You create a, cable connection. Then you can say you got an internet connection, and your organization is exposing some application or files to the public. So you just expose the application. That's all. So coming to each organization, they have their own local area network, and they will expose the application through the internet. Clear?
Yeah.
I'm all,
Yeah.
Yes.
then there's no doubt we can wind up, right?
Sure.
Yeah, sure. Thank you.
Thank you. Have a good night or good
Have a
morning
good
based
day.
on where you are.
Good
Good night.
night.
Bye.
Bye bye.
Good night,
Bye.
guys.
Thank you. See you.